Good day, guys. My name is Rivaldo Novella from Focus Academy, and I'm going to be your tutor for ATE 1A. Okay, so today we're going to be dealing with chapter 1. Okay, chapter 1 introduces statistics, so we're going to be doing the introduction to statistics. Okay, let me go through the learning objectives first, so that you can get the holistic picture of actually what we'll be dealing with in this learning unit. Firstly, we'll describe and discuss the concept of a population, a sample, parameter, a statistic, random variable, and data. Okay, I hope you guys have a notebook with you so that you can be able to write some few things down. Okay, so I need you to draw a table. Okay, and then on the left side of on the left column of your table, I need you to write population, and then on the right side of your table, on the right column of your table, I need you to write sample. Okay, because these things are a table, because these things are related. The population and sample, they are both related, so it's important for you to understand them by looking at both of them so that you can be able to understand them in a deeper level. Okay, we're going to be dealing with parameter and a statistic. I need you to draw another table, and then on the left column I need you to write parameter, and then on the right column I need you to write statistic, because a parameter and a statistic are actually similar in some manner but not the same, so it's important for you to understand them by looking at both of them at the same time. Okay, and then we're going to be dealing with the random variable, and after we're going to be dealing with the data. Okay, so secondly, we'll distinguish between descriptive and inferential statistics. Okay, after that, then we'll deal with what we will identify data types, and then identify measurement scales that are used to extract data from these data types. Okay, and after that we'll distinguish between the difference. We will distinguish the difference between raw data and frequency data, and then lastly we will explain more about the sigma notation, but you don't have to worry about the sigma notation right now because we're going to be dealing with it. You're going to encounter it firstly from learning unit 4 when we're dealing with Pearson's product moment correlation coefficient. Okay, so I'm going to discuss a few concepts of statistics, okay, so that you can be able to learn the language of statistics. Okay, the first concept is population. A population is actually the entire collection of individuals, objects, or items. Okay, a population can be finite or infinite. Okay, an example of a population could be, for example, if I gather data from all 50 ATE students in a lecture hall, then those 50 ATE students are my population. Okay, so and then after, the population can be what? Finite or infinite. A finite population is a population that is countable, and an infinite population is a population that is uncountable. An example of a finite population is, for example, shoes manufactured in a factory at a given day. So it's possible for you to actually count the number of shoes manufactured at this factory in a given day. Okay, and also the population, I said, it can be infinite. So what's an infinite population? An infinite population is a population that is uncountable. Okay, an example would be the outcomes of flipping a coin repeatedly. as you flip a coin repeatedly, new data keeps coming up, so this data has no end, so we call it infinite. Okay, then I'm sure you have written something in your table, as I asked you to draw a table and then and write population on the I think was the right or left column, and so on and so forth. So I'm sure you've written some notes about a population. So, and then we get to parameter. Before we go to sample a sample, and then let's explain a parameter first, okay? So we have a parameter. What's a parameter? A parameter is a constant value, usually unknown, that describes some measurable aspect of a population. Okay? For example, if I calculate the mean using data I gathered from the entire population, which is the earlier example, which is the 50 students in 80 students in a lecture hall. If I gather data from them and then calculate the mean from that data, then we call that a parameter. An example would be if I was actually measuring the height of students in a lecture hall, of 80 students in a lecture hall, and then I calculate the average height of those students, that mean would be my parameter. So any number I calculate using data from the population is called parameter. So, and also a parameter is usually denoted by, parameters are actually denoted by Greek letters, okay? So, but we will get to the notations very soon, okay? So, and then we have a sample. So I need you guys to compare a sample and a population, okay? Through the table I told you to draw, okay? A sample. A sample is a subset of the population of interest. Referring to the earlier example of 50 students, 80 students, as I told you that 50 80 students or 50 80 students are my population. If I then decide to take only 10 students from those 50 80 students, and then I measure data or count or collect data from only those 10 students and calculate maybe the mean or any other number, and then those 10 students are called a sample, okay? So if I only take 10 students from those 50 students, those 10 students, you call them a sample, okay? As you can see, a sample is derived from a population. And then we have a statistic. So I told you to compare a statistic with a parameter, okay? So a statistic is a number calculated from a sample data, okay, which describes a measurable aspect of a sample. For example, if I take a sample of 10 students from the population of 50 80 students, and then I calculate a number, any number, for example, the mean or the average of height of those 10 students, if I'm measuring their height, okay, that average would be called a statistic. Why is it called a statistic? Because I have calculated that value using sampled data. Remember, if I had used population data instead of sample data, I would call that value the parameter. But now I'm not using the population data, I'm using only sample data. So I'm calling it what? A statistic. So I hope by now you know the difference between those ones, okay? And also we have a sampling unit. A sampling unit is the object being measured or counted or observed, okay? So if I'm measuring the height of 80 students in a lecture hall, my sampling unit is what? Is the student, okay? Because I'm taking the data from the students. So that's what a sampling unit is. So we have also a random variable, okay? What's a random variable? A characteristic of elements of a population or sample for which the observed values differ from element to element is called a variable. An example of a random variable would be if I calculate, an example of a random variable would be that if I measure the height of students in the lecture hall, my random variable would be that height. So it's a characteristic I'm actually measuring, the height. Another example would be if I am actually recording the color of cars passing through or passing by the University of Johannesburg, the color of cars would be my random variable. Okay? Then we have data. Data is a collection of all variables measured, okay? For example, if that individual value, when I write it, that I write down when I measure the height of students, when I write that specific number, maybe the first height would be maybe 1.4 meters, 1.4 meters, and then the height of the second student would be maybe 1.5 meters. These values are called my data. Okay? And also we have descriptive statistics and inferential statistics. Okay? So we must differentiate between the descriptive statistic and also the inferential statistic. Okay, let's start with descriptive statistics. So descriptive statistics comprise of those methods used to organize and describe information that has been collected in a sample. For example, if I collect information from 50 ATE students, then I calculate from that data, I calculate the average height of students, of 50 ATE students. That process is called, it falls under descriptive statistics, okay? And also, contrary, we have inferential statistics. Inferential statistics comprise of those methods and techniques used for making generalizations, predictions, or estimates about the population using the sample data. A simple example would be, for example, if I then calculate if I take a sample of 10 students from 50 ATE students, and then I calculate the average height of those 10 students, and then the answer would give me maybe the average height of the sample data would be 1.4 meter. And then from these findings, and then I use this number to make a generalization, maybe for example saying the average height of all 50 ATE students is 1.4 meters. You see what I did here? I only used the data from the 10 students to calculate the average, but after that I use that average to make a generalization about what the population. Okay, so that's what inferential statistic is. And now we're going to move to understanding data. So we have two types of data, okay? We have categorical random variables or categorical data, and also we have numerical random variables or numerical data, okay? Same thing. So categorical, let me tell you the difference between categorical variables and numerical variables, okay? Categorical variables are also known as qualitative variables, okay? Such variables allows for classification based on some characteristic, okay? So categorical variables, we only classify them, And an important thing about categorical variables is that we cannot perform arithmetic operations on categorical variables, okay? An example, let me give you an example of a categorical variable so that you can be able to understand it deeper. For example, let's say we are measuring color, the eye color of students. So, as I told you that we cannot perform arithmetic operations on categorical variables, and by performing arithmetic operations, I mean that we cannot add one value to another value or of the data. We cannot do that, or subtract a value to another from another value, or divide or multiply. We cannot do that. So for categorical variables, so it's actually a standard we use to identify categorical variables, is that we cannot add one data value to another. An example would be when we are measuring, we are actually collecting information about the eye color of students. When we cannot add one color to another color. It's impossible for me to add blue with maybe white. That's very impossible. This does not exist. We don't add colors. So we only do what? We only classify colors. Okay? We don't add them. We classify them into blue and then this side white. We only classify them and then we cannot add them. Contrary, numerical random variables are naturally measured as numbers and are also called quantitative variables, okay? And are also called quantitative variables. So numerical random variables can be discrete or continuous. Okay, before explaining the difference between discrete numerical variables and continuous numerical variables, let me explain to you what a numerical random variable is. So a numerical random variable is a variable that is naturally measured as a number, and then also we can perform arithmetic operations on the numerical random variable. For example, we can add one value to another. An example is if I measure the height of students, maybe the first answer would be maybe 2 meter, and then second would be 1.4 meter. So I'm allowed to add this 2 meter to 1.4 meter, and I'm also allowed to subtract 1.4 meter from these 2 meters, so I can be able to perform arithmetic operations on the data, so which makes it numerical random variables. So that's how we identify them. We can be able to perform arithmetic operations on them. Okay, so as I said that numerical random variables can be discrete or continuous. Okay, numerical random variables that are discrete are the ones that are obtained by doing what? By counting. And continuous numerical variables are only measured. An example of a discrete numerical random variable would be, for example, when I count the number of children in a household. See? And then, for example, we do not measure the number of children in the household, but we do what? We count them. Okay? Contrary, continuous numerical variables are measured instead of counting. For example, the height of students. We measure the height of students and we do not count the height of students. So that's the difference between continuous numerical variables and discrete numerical variables. And then we will then get to measurement scales. Okay? We have 4 measurement scales. Okay? Namely, nominal, ordinal, interval, and ratio. Okay, so what are measurement scales? Measurement scales is actually scales that we use to extract data from our variables. Okay, so as I said, we have categorical variables and also we have numerical variables. Okay, so we only use nominal measurement scale and ordinal measurement scale to extract data from categorical variables, and we only use interval measurement scale and the ratio measurement scale when we are extracting data from what? Numerical variables or numerical random variables, same thing. Okay, so now I'm going to discuss these measurement scales one by one so that you can be able to understand them deeper. Okay, the first measurement scale is, before I explain the first measurement scale, I need you to have a book with you so that you can make some notes. Okay, so be ready to make some notes so that I want you to jot down whatever I tell you to write. Okay, so I'm going to give you a standard that is required for you to use the nominal scale, ordinal scale, and the interval scale. The interval scale and the ratio scale. So these standards I'm going to give you will help you identify the differences between these different scales. Okay, and when should we use one? Okay, on your notes write the word nominal. Okay, so when do we use the nominal measurement scale to extract data? We use it if as I told you that we use the nominal measurement scale and the ordinal measurement scale to only calculate to only extract data from categorical random variables, so categorical data. Okay, which is data that is classified and not measured as numbers, for example the eye color and stuff. We use the nominal and the ordinal scale. Okay, so these two go together. So number one, nominal scale. When do we use the nominal scale to extract data from the categorical variable? If the data has no, we use it if the data has no intrinsic order. This means that when the data has no specific order, for example, you can write it in any order. And another example is that when we are taking information about a person's eye color or person's maybe color, or let's just stick to eye color. Okay, if we are taking data about people's eye color, it doesn't matter whether I start with blue or green, or I start with green and end with blue. Okay, so it doesn't matter. So this is a G, please understand. Yeah, so order doesn't matter. If your random variable does not have any intrinsic order, or the order in which you record your information or data does not matter, then we use the nominal scale. Contrary, we have the ordinal scale. We also use the ordinal scale to measure data from to measure categorical data. Okay, so when do we use ordinal scale instead of nominal scale? We use the ordinal scale if the data can be ordered or ranked. Okay, so if I can be able to rank my data, or there is a specific order in which my data follows, then I use the ordinal scale. Okay, an example would be when a person's age is classified as young, middle-aged, and old. Okay, You see, this follows a specific order. Okay, so you cannot start with old, then you go to middle age and young. No, you start from being young, and then you grow, you become middle aged, and then afterward, and then you become old. So it's an order. Okay, there's an order. We can rank these. Okay, this one is smaller than this one, or this one is bigger than this one. Okay, so they can be ranked. If categorical data can be ranked, we use the ordinal scale to extract data from our categorical random variable. Okay, and so we have the interval scale and what, and the ratio scale. These two, we use them for only numerical random variables. Okay, so when do we use the interval scale? I'm going to give you standards. I need you to write them down, that you're going to refer to when you are actually referring to the interval, when you're actually deciding whether the data is measured on an interval scale or the ratio scale. So I need you to write this down. Okay, a numerical variable, a discrete or either discrete or continuous, is measured on an interval scale if, then you write that semicolon to indicate that you're going to write some few points underneath. Point number 1, or standard number 1, is 0 is an arbitrary reference point, which means that 0, in brackets you can write that, which means that 0 does not mean that there's nothing. Okay, and then number 2, the second standard is that the difference between the data values is meaningful. Okay, I repeat, the difference between the data values is meaningful. Okay, in brackets you can say that, for example, the difference between 20 and 10 is the same as the difference between 30 and 40, which is 10. Okay, and then the last standard, or the third standard, is ratios between the variables are not meaningful. Okay, I repeat, ratios between the variables are not meaningful. Okay, so what we're going to do is, I'm going to make an example for you to understand when to use the interval scale to extract data from numerical random variables. Okay, let's take, for instance, we are measuring temperature. Okay, 0 degrees, when we measure a temperature and then it gives you 0 degrees on your thermometer, 0 degrees does not mean that there's no temperature. See, standard number 1 has been met, which says that 0 is an arbitrary reference point, or 0 does not mean that there's nothing. Okay, okay, and then the second standard says that the difference between the data values is meaningful. Let's just check that. Okay, so the difference between 10 degrees and 20 degrees Celsius is the same as the difference between 30 degrees Celsius and 40 degrees Celsius. Okay, so the standard number 2 is met. So standard number 3 says that ratios between variables are not meaningful. Okay, so let's check if the ratios between the temperature are meaningful or not. So the answer is, when we are measuring temperature, if you have 20 degrees, it does not mean that you have twice as much as 10 degrees. Okay, it does not mean as that you have it is actually twice as hot as 10 degrees. Why? Because they are using scales that are not actually accurate, and also there's no true, or there's no true 0. Okay, so if there's no true 0, so we cannot measure accurately the how twice a temperature is, okay. So it does, so this information satisfies the last it satisfies the last standard, which says that the ratios between variables are not meaningful, okay. So 20 degrees Celsius does not mean that it's twice as hot as 10 degrees Celsius, okay. So this is when we use an interval. Another example is when we are measuring IQ, but think about how IQ could apply to this information, okay. Then we come to the ratio scale. Remember, we use the ratio scale only for numerical data, okay. We use the ratio scale only for numerical data or numerical random variables, okay. So when do we use the ratio scale to measure or to extract information from our numerical random variable? I'm going to give you standards, okay. I need you to write them down, and then under the topic ratio, or the word ratio, write the following. And a numerical value, whether discrete or continuous, is measured on a ratio scale if, then you write the semicolon. Number one is there is a true or absolute zero, and then in brackets you can write that 0 means that there's nothing, okay. Then standard number 2 is the difference between the variable values are meaningful. So in simple terms, the difference between 20 and 30 is the same as the difference between 10 and 20, which is what? 10, okay. So that's what standard number 2 means, okay. So standard number 3, or the last standard, says that the ratios are meaningful, okay. So you're going to understand this much better if I use the example of the amount of money you have in your bank account, okay. Let me use that example for you to be able to understand more properly, okay. For example, say if you have in your bank account, if your balance says 0 rands, ask yourself, does that mean that you have no money, or it means that you have money? So the answer to this is that it means that when you have 0 rands, it means that you have no money. So standard number 1 is satisfied, which says that there is a true or absolute 0, or 0 means that there's nothing. See, if you have 0 rands in your bank account, it means that you have nothing, okay. So standard number 2 says the difference between variable values are meaningful, okay. So to that, which means the difference between 20 rands and 10 rands is the same as the difference between 30 rands and 40 rands, okay, which is what? 10. So standard number 2 is met. The second standard for ratio and interval, if you noticed, they are the same, okay. And then the last standard, which says that the ratios must be meaningful, okay. So this is satisfied by, for example, if you have 20 rands in your bank account, it means that if you have 20 rands in your bank account, it means that you have twice as much as what? 10 rands. So the last standard is satisfied. The ratios are actually meaningful, right? Then the next topic, or second last topic, is about data formats. Okay, we have two types of data formats. Number one, we have raw data, and then number two, we have frequency data. Okay, so what's the difference between raw data and frequency data? Raw data is unprocessed information. I like to call it as information that is freshly harvested from the variable. Where it's unprocessed information, we have not done anything, we have not added anything to anything, so it's data as it is. Okay, an example of raw data could be what? Maybe measuring the height of students, and then the height of student number one would be maybe 2 meters. Okay, second student maybe 1.5 meters, third students maybe 3 meters, and so on and so forth. So if data is in this form, it's called raw data or unprocessed data. Okay, so frequency data is actually record data in an aggregated format. Okay, it records data in an aggregated format. So what does this mean? It records the number of a variable, and then it records the number of times it appears on the data set. For example, let's say we had data in this form 2, 3, 4, maybe 8. For example, you have data in this format. Okay, as we have said, maybe this is actually raw data. Okay, and then frequency data, as we have said, is data in an aggregated format. It's actually written in the form of a table. Alright, and then here you write the value, and then here you write the frequency. Okay, so here you write the value, and then on the right side you'll write the number of times the value appears on your data set. An example is, for example, value number 1 is 2 on our data set. Sorry, let me remove this thing. Okay, example, say we have the first value is 2, and then on the right side we write the number of times 2 appears. For example, 2 only appears 2 times in the data set, so on the frequency side you write 2. Okay, and then the second value is 3. As you can see on the data set, 3 only appears 1 time, so you write number 1 on the frequency. Okay, so to indicate it only appears 1 time on our data set. And then the third value is 4. It appears only once, write 1. And then the last value is 8. And then it appears twice, write 2. So this is a frequency data format, and this is raw data format. Okay, so I hope you understand the difference between the two. Okay, and also we have the sigma notation. As I said, you encounter the sigma notation in the in chapter number 4 when we're going to be talking about Pearson's product moment correlation coefficient, but you have to know what it means right now. So this thing is the same as this, okay? It's a sign that represents summation. This means the sum of all x's. This sign is interpreted as the sum of all x's, okay? That's the interpretation of it. And an important thing is that the square of a sum is not equal to the sum of sum of squares. So if we have this here, we interpret it as the square of a sum, and then it's not the same as this here, which is interpreted as the sum of squares. So let me do a quick example for you to be able to understand this, okay? Let's say we are adding numbers 2 or okay, plus 3 plus 0. Okay, we are summing up these numbers, okay? Or sum of x, yeah, it's actually equals to, this was 2 plus 3 plus 0. Then the square of a sum, which is this notation, means that you add all the numbers and then the final, and then you square the final number. Okay, let's do that. 2 plus 3 plus 0 is equals to what? 5. And then 5 to the power 2 is equals to 25. Okay, it's equals to 25. So this is the square of the sum. Alright, you sum up the values and then you square the final, or the answer to the summation. Okay, so this is this. Okay, then the second one, it says that the square of a sum is not equal to the sum of squares. Okay, so the sum of squares is this sign. Okay, let's take, for example, we are adding 2 plus 3 plus 0. So if we want to get the sum of squares, which is this sign, we square each number and then add the answers. Plus 0. Okay, so this will be equals to, equals to 4 plus 9 plus 0. Okay, 0 to the power 2 is equals to 0. Okay, plus 0. So this will be equal to 9 plus 4, which is 13. As you can see, 13 is not equal to 25, so which proves that the square of the sum, which is this, I'm sorry, I was supposed to write, okay, which is actually this, it's not equal to the sum of squares, which is this. Okay, so that's the interpretation of this statement, and that's all about sigma notation, but you don't have to worry much about the sigma notation. So, and then the last thing, I'm going to show you how to enter data into your calculator. Okay, I'm going to show you how to enter raw data into your calculator. So why do we need to enter raw data into your calculator? We need to add raw data into your calculator because traditionally you were required to do what for example, when you are required to calculate the mean or average of information, you were required to manually add those numbers, and after that you divide them by the number of the variables, and then you get your average or the mean. But in statistics, we use the calculator to calculate values such as the mean and stuff, and variance and all of those stuff. So for you to do that, you need to be able to enter raw data. So in learning unit 2, we're going to learn how to enter frequency data. So now let's start by learning how to enter raw data. Okay, step number 1, you must access the setup. So on your calculator, on the top left part of your calculator, there's a button. On top of it, it's written shift. So, and then also on the top right part of your calculator, there's a button written mode setup. So let's start. Okay, no, number 1, you need to access the setup. Okay, how do you access the setup? You press the shift button, and immediately after letting go of the shift button, you press the mode setup button, and then you'll be presented with options. So number 2, you press the down arrow, and after that you'll be presented with few options, and then you press option number 3, which is stat. And then after doing that, it will ask you frequency. Then you choose number 2, off. We are turning off frequency because we are not entering frequency data, we are entering raw data. Okay, then number 2, what we do is we access the mode. After switching off the frequency in number 1, number 2, we access the mode by pressing the mode setup button, and then you'll be presented with a few options, and then you press number 2. After that, you'll be presented with more options, and then you press option number 1, which is 1-var. Okay, and then after that you'll be presented with a column labeled X, and then all you need to do is to enter data values by pressing any any number that you are dealing with. For example, let's enter maybe 5, or then you press the equal sign, and then the data will be recorded. You press 7, you press the equal sign, the data will be recorded. 8, equal sign, the data will be recorded. And then after that you press the AC button, then your information will be recorded. So I'm only teaching you how to, this time I'm only teaching you how to enter raw data. Okay, so I've taught you how to enter the raw data. So the second step would be maybe to calculate, to command your calculator to calculate maybe the mean or variance and stuff. So, but now we are not dealing with that. We are only dealing with entering raw data. So we have entered the raw data. So now to bring your calculator back to normal, you need to find a button which on top it's written CLR. On my calculator, CLR is number 9, so you need to press the shift button, and then you press the CLR button. My calculator is number 9. Immediately after letting go of the shift button, you press the CLR button, and then you press number 3. It will ask you here, then you press option number 3, and then it will ask you whether to reset all, and then you press the equal sign, which is yes, and then you press, after that you press AC, and then your calculator will be back to normal. So this is learning unit 1, and next we'll be dealing with different activities to apply the information we actually have learned in learning unit 1. Thank you.